Hello friends, welcome back to Compiler Hacking. In the last video, we worked on our math module and the square root function. I wasn't too happy, if you watched until the end, I wasn't too happy with our implementation. The code we had to write, all this C++. I wanted something a little bit neater. And so in this video, I'm going to try, if you're watching this, then maybe it was successful, or it was so catastrophic that I thought it was entertaining to watch anyway. So hopefully it worked out. But what I want to write is just some more Ruby-ish code. I want to write this the way I would in Ruby, and then just call sort of like FFI, foreign function interface. It's not really FFI because we're going to compile it ahead of time, but it's going to feel that way. So what I want to do is, this same Ruby code, which replaces all of this, all of that, I believe. And then I want to define a function. So this is going to be some more of these double underscore compiler directives. So I want to define a square root, and this is the name. I don't know if I should give it like another name. I think this is fine for now. The number of arguments and what their type is, and then what it returns. In this case, it's very simple because it takes a double and it returns a double. And so we define this function at compile time, and then we call it with this special syntax call, same thing, sqrt, and then pass in the X variable, and that should be returned, and that's the code I want to replace this. Of course, none of that code works. If I run my square root spec, then I want to get some funky error here, but let's see what we can do to make it work. I really didn't expect this. I'm not sure what went wrong here. So let's run this with GDB, I guess. Oops. Does that make any sense? Did I get a seg fault or something? What in the world? Terminate, raise exception, raise, find method. Fascinating. I guess the call method? Wild. I mean, I don't think it matters because I'm going to be replacing this at compile time with other code, so I don't know, it's kind of weirded me out that it's getting that weird error. Okay, but that's fine. We'll do that, and then in pass 4, which currently is where our let's go to pass 4, where our compiler directive stuff is, all these underscores. This comes from the Natalie inline. It's not really a package, but it's sort of a way to tell a compiler to do stuff at compile time. We want a new one, actually two new ones. One called function, and then another one called call. Okay, so function is going to take a name, args, and return type. exp, let's just print those out. Args, return type. And then this one's going to take a function name and then args. And let's print out those things. Just kind of see what we're in for here. And then we'll just have these return nil, just so nothing blows up. Huh. Cool. Do I need to recompile that file? I think it doesn't recompile that. Fascinating. Function call. Huh. What's going wrong here? How? Raise. So if I go to frame 11, print class name, no method error, print message is a string, C stir. Undefined method function for class. But that should be intercepted by the compiler. Process function. I did that correctly. Oh, I'm not. There's somewhere else, I forget. Where do we do that? It's in compiler, RB, inline, CPP enabled, inline. Where do we do that? Inline CPP enabled. Okay. Pass 1. Oh, interesting. Oh, these have to be passed through. That's what it is. Okay. Function call. Oh, I don't need that anymore. Let's run that. Cool. Totally forgot about that. That's what happens. Oh, okay. But I didn't save this. There we go. So we've got a string. Oh, okay. Yeah, thank you very much. We've got an array of strings. We've got a string. We've got another string. And then we've got an lvar. Cool. Well, let's work on these three. Let's work on the function stuff. Function, that's over here in pass 4 function. I'm going to split this file into 2 and then go up to the top. I think that we have, let's say, do I want to call it FFI? We'll just call it functions. Let's say inline functions. And then give it a hash. And then I want to save this. So I'm going to say inline functions. Name. I want to verify that's a string. Def comp time string exp. I should have done this a long time ago, but I didn't, like right here. So I just want to paste this. Raise expected string past expected string at compile time, but got exp, and then what I want to return is exp.last. I don't need the return, and let's just make this a little bit easier to read. Perfect. Comp time string. We'll call that a comp time string. So name equals comp time string name equals, and then this is we're going to be saying args, and this is going to be comp time array of strings. Array. We did array at compile time. We got that. Now we're going to say array map do item comp time string item. Does that make sense? For now it does. I think it's perfect. Args is comp time array of strings, and this is args. And then return type is a string. Comp time string return type. So now we have created this inline function thing that we're going to store. So we know anytime we reference this name, these are its arguments and this is its return type. Let's just see if that blows up first of all. See what happens. I didn't get really anything out of that. Fair enough. Maybe I shouldn't expect anything out of it. I expected to see something though, didn't I? Yeah, I'm expecting to see these. So am I right back where math RB? I need to save this in order for it to recompile. Yes, there we go. Undefined local variable or method array pass for 191. Okay, 191. So it's not array, it's exp, and then I need to save this. I'm not convinced that that worked. Okay. Perfect. Now, when we do a call, we can say fn is comp time string fn, and say fn, let's just do this, inline functions. And let's do fetch so we get an error if it doesn't exist. And then let's print the function like so. Oh, I should really just stop doing this. Let's do it manually. Save that, run that. Do your thing, do your thing. Okay, did we get something out of it? Did we get something? We did. We got its arguments and its return type. Perfect. So, what does arguments look like? What does it look like? Lvar x. Oh, I still want this to be processed. I don't want this to be Lvar. I don't. No. Pass 1. I want call to behave differently. So let's move this. Let's zoom out here. So get rid of this. If move that up here. Oops. Here. Do. And if method is call, then I want to do something. What do I want to do? Pass 4. Nope, that's pass 2. Pass 4. It's a little slow. I don't want to do anything to the first piece, the first item in the expression. I only want to do the rest. Okay, so turn exp new method exp args first, unprocessed, and then I want to process all the rest. Args 1, that map, arg, process atom, a, boom. I'm going to process all the rest of them. Save you, run you, and blow up. No, I didn't blow up. Good. But it didn't do anything. What? I saved that. I ran that. What am I missing? If method is call, this is an array of symbols. I'm returning this. Oh, I need to star that, I guess. Or do I? I don't think it matters. But I'm not getting anything. Nothing happened. Nothing got printed when it was compiling. In fact, it didn't compile anything. Why not? Why did nothing change? Maybe I should do rake clean every time. Okay, I got it. Let's do this. Let's do rake clean build. Let's run that. It'll be a little slower, but I'll be sure to get all the new code every time. I think my build setup is not recognizing certain changes, so. Oh, there it is right there. I saw it. Double and double. Math x26. Ooh, yeah. That was it. So interesting. I'm a little puzzled why it's not an array of items. Okay, this is good. Unknown node type var get. Unknown node type var get. Base pass sex boo 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 boo. Interesting. Where are you coming from? Very recursively. Maybe not process atom, just process. And this needs to be a star, and this, I don't know, it doesn't seem quite right. Kind of just guessing at this point. So those are the arguments. They did get passed in pass 4. Good grief, I have way too many files open. Okay, let's close everything else. Pass 4. And this should be a star, because each argument is going to be passed in here. And the arguments I got looked like a literal variable, but I don't know what type that is. It doesn't matter. I know what type the function takes, so it's going to assume, it's going to make an assumption. It's going to make an assumption. So, now what? I think I just want to replace this with the function name and parentheses. And what? This is going to be the args.map. Each argument is what am I getting here? I'm getting a literal C++ variable, math x26. And what I want here, let's just write what I want. Math x26 as float to double. That's what I want. And then here I want to do return. Return? No, not return. I want to do value, and this just accepts a double. Okay, so how do I get to there? Let's do convert value is this little lambda. Let's make a lambda v and type, T for type. Case type when double, then do something else, raise. I don't know how to convert type T. I don't yet know how, but I will. Double. Then what I want to return is, I'm going to assume that it's always this L thing because that just makes it simpler for now. I know it's not always that, but we'll let that blow up later. We'll say raise fix me unless t.sexput type is L. Last as float to double. Convert value. Convert value? Convert cast value. Cast value. Yeah, we'll say cast value. So that's how we're going to handle each one of those. And then inside of here, we're going to do args map args casted args is args.map do arg, and I need an index, each with index.map index. Okay, the type is now function args index and then we do cast value arg casted args. So here we do casted args join comma parens. Let's just see how far off this is right now. I know we're not branching for the return type yet. We'll just assume it's always a double. How bad is this? How bad is it? What did we get here? No method error. Undefined method cast value. That's right, because I have to treat it like a lambda and use a little dot. That's our weird Ruby syntax for calling a lambda. So let's go down here and see what the next error is. Wrong number of arguments given 1, expected 2, because I didn't pass the type. Try that again. Oh, this is exciting. I think this is going to work. I think it's going to work. I don't yet know how to convert type double. That's because I used a symbol instead of a string. So let's fix that. Okay, now what? Undefined method 6 type for double string, pass for 211. Not what I expected. Type. Oh, not T, V. Yeah, just use the wrong variable name. We're going to get there. We are going to get there. Oh, we're getting some code. That's not what I expected. I need the name. So this is function name. Name. Function name. I'm stoked. It's gonna work. It's gonna work. S was not declared in the scope. S stir square root. Okay. We'll do this. fn name is that. fn name. Let's try that again. We're getting closer. Awesome. Okay, we made some assumptions, right? We made an assumption about the return type. We're going to say result. Is it result? Let's say call result. That's the code for that. And we want to put this in a string. We're going to say case. Yeah, this is cast value. Okay, we need to rename this. Cast value to CPP. To CPP. And then I need a cast value from CPP. From CPP. When it's a double, then we do a value and then V. I don't know how to cast type. We'll say return type. We'll say arg type. That way we can figure out which error it is. Call result. And this can just be cast value from CPP call with the return type. FN return type. I think. Seems right. Is it gonna work? What did I break? I think it worked. Let's go look at the generated code. Edit build generated math.rbcpp and hypotenuse. We don't care about hypotenuse. Square root 12 is right here. Look at this beautiful code. That's all the rescue stuff. Here's the one-liner it generated called square root math x26 as float to double. I didn't hard code this, right? Now I'm nervous. Math x26. Math x. No. Okay, I did the right thing. Because the argument. How does that work? Because. Oh, right. We're assuming it's that. But we should probably do it the other way too. So let's add all this to the index. Get add math RB. Let's go look at this. What if we force X to be captured? So we create a lambda that prints X, and then we call that. That will break. Okay, and that broke. No such file or directory. That's fine. Fix me pass 4 line 210. So we're going to go fix that to right here. And we left a nice note for ourselves. I'm going to say actually I want to raise what it is. V inspect. What is the actual thing? Now get a better error. It's a var get env yada yada yada. How do I handle that? I need to process it, don't I? Oh, maybe I always just process it. It can't be that simple, can it? I'm in the compiler. What's happening? Oh, I'm calling that. So does this work both ways? Let's look at the generated code. Generated math 203. So here's the one-liner here. Math var get 104, and we had to call var get on the environment because it's a captured variable. If I remove that, it's no longer captured. This code will change. And it did. I went too far down. There it is. Math x26. It's no longer captured. It's just a regular C++ variable, and it's not stored in the environment. And this is beautiful. This is so beautiful. Look at that. Look what we did. We can only do doubles right now, but that's okay. It's a start. We know how to convert or cast from our object type to a double, and we know how to cast from a C++ double to our object type. And it works great. It works just fantastically. Let's clean this up a little bit to make it a little easier to read. Is there anything else we can do over here? I don't yet know how to cast argtype. This will be useful when someone tries to use this, like with an int or something. They'll get this error and they'll know to come here and fix it, which shouldn't be too bad. This is so cool. This is so cool. This is going to let me clean up all kinds of stuff. I think dir_rb has some stuff in it. Look at all this C++. I think the reason was we had to call opendir and readdir. I mean, there's probably a lot to be gained. I don't know, this one might be a little more complicated, but right here, I think we're just using rmdir. That's the only C function we're calling, I think. So this could definitely be cleaned up because it's just going to take a string and it's going to return an int. So yeah, I'll leave that as an exercise to someone. If you want to jump in and help out, if you want to work on our new little, I don't know what to call this, inline function auto cast thingy. I mean, it's kind of like FFI, but it's not doing it at runtime. It's doing it at compile time. So cool. So cool. Anyway, let's commit all this stuff. That's done. Clean. Let's see. Add inline function call. Let's see. Inline C++ function call to Natalie inline. Let's just say add C++ function call ability to Natalie inline. Now we can get rid of a lot of boilerplate C++. when all we need to do is call a C++ function. This is cool. I'm just going to admire my work. I'm just going to admire it. So cool. So we had to change something in pass 1 because I had to treat call a little bit differently because we kind of wanted it to partially evaluate it. We wanted it to compile the first argument. No, we wanted to ignore the first argument, but compile all the rest as it normally would. That's how the variables work. I added these comp time array of string just as a helper because I was tired of writing this sort of boilerplatey code. We have this inline function, which it just kind of stores the argument types and the return type. And then we have the call, and this is what does the meat of the work. These could probably be methods. They don't have to be lambdas, but at least it's all self-contained. And it's only 15 or 20 lines of code, so that's not too bad. And look at what we gained. So this code, which if you watched my last video, you saw it was kind of a pain to write because you're in a string inside of Ruby, and maybe your editor is better than mine, but my editor did not know that was C++, so it was not helping me at all. So we went from that to this beauty right here. And I think all the tests are passing. Just make sure that square root spec is passing and that hypotenuse spec from last time. Make sure that is also passing. Hypot spec. Sweet. Hey, thanks for hanging out with me on this video. I hope you learned something. I just get such a thrill out of doing this stuff because it's in the realm of, is that possible? I'm not sure. And then you dive in and you figure out it is possible, and it makes you feel so good. I don't know. It's like an adrenaline thing for me. I'm such a nerd. With that note, I will sign off. I hope that you had fun, and I hope to see you in the next video.